Hello, and this is my masterclass series, video number 4, which is the last one. Okay, here are the learning objectives to be able to understand how to find the length of the curve, surface area, and how to find centroids. And let's start with our topic. Here is length of the curve. Let's say we have a curve here, and these are the limits. Wait, in the x-axis, so this is gonna be A, and this is gonna be, and the curve is gonna be the Y, and and in the and and in the Y-axis, their limits are going to be um D wait they're going to be D and C here. So you always need to know what are the limits and if it's in the x-axis or in the y-axis. So if it's in the x-axis, you use this formula, which is integral with the upper limit of b and lower limit of a with the square root of 1 plus derivative of y squared over dx. And for the and if your limits are what do you call this? Based on the y-axis, so it's going to be you're going to use D and C instead. But it's very flexible as you can instead if let's say for example the limits are given are B and A based on the x-axis, but the function given to you is x. So you just can convert it into a to the function to the you can just convert it into y. So so you can use you can use this formula or just get the lower or you can just either that or you can just get D and C so that you won't change the value of x given to you. So okay, let's move on to our problem. Okay. Okay. Here is our problem. Determine the length of y is equals to ln sec x between 0 to x pi divided by 4. Okay, so if I remember correctly, wait, so okay. So if we are going to write this problem, it's going to look like hmm wait, It's going to look like this, and pi divided by 4 is about here, and this is 0. So we need to determine the length of this. Okay. Okay, using the previous formula we had, we need to first get a derivative of y. No, wait. Of y, and ln sec x is just tan x. And as you can see here, we already gotten the integral of y. So that's just going to become, so wait, 1 plus, so it's just going to become, we have the formula here in the upper right, so let's use that. So going to become b is 1, a is 0, oh no, a is 0, square root of 1 plus, no, 1 plus tan square x over dx. And 1 plus tan squared x is just equals to secant squared x. So we can rewrite that as second. This is going to be secant squared x, and the root of that is just sec x over dx. Wait, I forgot. The limit here is not 1 but pi divided by 4. So this is also pi divided by 4. Okay, so that's going, if we find that, it's going to become ln sec x plus tan x pi divided by 4, 0. So that's just going to be 0. So that's just going to become, that's equals to, wait, why what's happening with my mouse? Okay, that's just going to become ln square root 2 as secant times square secant of pi divided by 4 is equals to square root of 2, and tan is just going to become plus 1 plus c. And that's how you determine the length of the curve. Okay, let's clear, now that's the answer. So let's clear this drawing. Let's move to another problem. Okay. Okay. First, the problem here, we need to find the derivative of this. Wait, no, I need to first to go graph this. So it's just going to look like 1/2. So 1/2 is just going to become here. Wait, this is right. So it's just going to look like this, and with this. So from 0 to 1/2. Okay, let's let's find the derivative of x. Wait, no, undo. Let's find the derivative of x, as this is going to be 1/2 times 2y. So this is going to become just y. So using this formula, let's write it. So equals to b is 1/2, a is 0, square root of 1 plus y squared over dx. Okay, now as we can remember, we had a lesson about trigonometric substitution. So this in this we need to use y is equals to tan x with dy equals to wait, this is dx, not d. Okay, wait. This is going to be dy, and dy is gonna be what, second, if I remember correct, second squared theta d theta. Okay, so we can just resubstitute it now. So 1/2 0 square root 1 plus, wait, plus tan squared, tan squared plus second squared d theta. Okay, this is just going to become second squared. So okay, now it will just become equals to 1/2 0 second. This is going to become just second squared square root. So second, second raised to 3 d theta. Okay, okay. After now, I think we can solve for this. So it's just going to become if I remember correctly, second. So no, 1/2 sec theta tan theta. What's next? Can I do na? Plus ln, no? And sec theta plus tan theta. Um, hmm. Oh yeah, I forgot. I need to change the upper limits. Okay. So wait, oh, I forgot. Okay. Y is equals to 0. Then tan theta is equals to 0, theta is going to become theta is equals to 0 if y is equals to 1. So 1 is equals to tan theta. So theta is um it's if I remember correctly, it's pi divided by 4. Okay. So this is going to become pi divided by 4, 0. Okay. Now I think we can solve for this now. So just going to become 1/2. Um, mm, wait. Oh no, this is 1 and this is okay. This is going to be square root of um I need to first move this up. So square root of 2 um plus lm. Um, so it's just going to become 1 plus square root of 2 as this is equals to 1. Okay. So that's that and plus c. And that's how we solve the length, the arc, length of the curve of x is equals to 1/2 times y squared between x is equals to 0 and x is equals to 1/2. Okay. Now let's clear. Now this is my answer. So let's clear and let's move to another topic. Okay. Okay. Surface area. In surface area, let's say we have a wait. Undo. I need to use black. Let's say we have a axis of rotation here in on 5. And we have a cylinder on here. And it rotates on 5. So in order to get this, and let's say we have a curve which goes, let's goes like this, and we need to find the surface area of this cone, or you say cylinder. We need to use the formula for surface area. So in order to use that, we first need to get the limits. Let's say this is our limits. This is going to become this is gonna become A and this is B. And it's the same as our length of the curve in placing our limits. So if it's on the, let's say on the parallel to the y-axis, if our center of rotation is, so let's say this is our curve, and so our limits here are going to be D and C. So it just depends on the orientation. So if it's parallel to the x-axis or on the x-axis, use the B and A. and on y-axis, just use C and D. Okay, so this is the formula we need to use. And let's say the same problem I discussed um, with the length of the curve, that if the function given to you is equals to something, and the limits are b and a, you just need to convert it into y and get its derivative in order to use it on this formula. And that's how we get our surface area. So remember this formula. So let's clear this and let's move to a problem so that I can explain it properly. Okay. Here's number one. Let's move my camera here. Okay. Y is equals to 4 plus 3x squared. Okay. If we graph that, if we graph that, it's just going to look like something like this. So we need it from 1 to 2. Wait, line. So 1 to 2. So we need to get the surface area of this. We need to get the surface area of this. And it's rotated about the y-axis. So it's rotated about the y-axis. So it's going to become like that. So we need to find, wait, no. Let's draw another thing to look like that with a, let's see. Oh, it's going to look like that. So in order to solve for this, as we can remember, our limits are on x. So we'll use b and a. Okay, so it's going to become so 2, 1, then 2 pi y square root of 1 plus y, the derivative of y. And the derivative of y here is, as it's 4, that's going to become 0. So 3x squared. So that's going to become 6x. So 6x, wait, let's undo. 6x raised to 2 is going to become 36x squared over dx. Now, so after that, I think we can, mm, wait, mhm. I know what, okay, there's something wrong with my formula here. So instead of this 2 pi y, this is 2 pi x. So I just mistyped that. So let's erase this. So this is 2 pi x. Okay. So now we can integrate this. So if we integrate this, so this is going to become pi 54. If we integrate this, it's going to become pi 54 divided by 54 1 plus 36 x squared raised to 3 divided by 2 per 2 1. And now we can solve for this. So it will become pi 54 times if we calculator this, so it's going to become 145 3 halves minus 37 3 halves, which is going to become 88.48 4864, and this is the answer in the surface area. Okay, let's have let's clear this and let's have another problem. um, okay. as uh, as I said, this is x. Okay, so x-axis, and we have values of x. So first, we need to find the derivative of side of y here. So y, derivative of y is equals to okay, so 2 cos 2x. So going to become, so b is pi divided by 8 wait, I forgot. So um if we write if we graph this for this function, it's going to be wait, need black here. So it's going to look mm, like this, with this as pi divided by 4. So this is 0. Okay, sorry for the penmanship, as my hands is getting tired. So okay, so 2 pi x, 2 pi x. Okay. Hmm, wait, x. Wait, 2 Wait, no, no, that's not x. So, oh yeah, okay. It's going to become sine, I don't know, sine 2x square root of 1 plus, um, okay, so that's going to become 4 cos raised to 2x over dx. Okay, okay, okay. This, okay. Um, I need to use substitution here, so simplify. So, wait, if I remember correctly, we have cos 2x is equals to 1 half tan theta. Hmm. So for cos 2, okay, this is going to become tan squared theta. 1 plus square. Okay, this is going to be secant squared theta and square, so secant. So pi divided by 8, 0 to pi sine 2x per second theta. D theta. So we need to substitute this. So I forgot what I can substitute there. So, mm, oh yeah. Uh, I forgot. There's another formula we can use. So 2 sine, no, no, no. Negative 2 sine 2x is equals to 1 half sec squared theta. So you can just erase this. That's going to become negative. So negative 2. Okay, so that's going to negative pi over 2 over second squared theta. So you can also simplify that again. Okay, so second raised to 3 theta d theta. Okay. and we need to replace this. So mm, mm, so as we already have here, so if x is equals to 0 and cos x is equals to 1, so cos cos lang cos x is equals to 1, cos 0 is equals to 1, so 1 is equals to 1 half tan theta, and theta is equals to tan, ano no, arc arctan, so that's raised to negative 1, raised to 2, no, no, raised to 2, but times 2. So this is going to become 1.01, ano, 1.171. Okay, that's what I got in my calculator. So let's let's get the other limit. So x is equals to pi divided by 8. Wait, pi divided by 8, which is equals to cos pi, cos, cos pi divided by 4. Hmm, did, which is equals to square root of 2. I don't know. Oh, yes, square root of 2 over 2. After that, which is equals to 1 half tan theta, and theta is equals to, hmm, no, is still going to same like this. So arc tan instead of 2, square root of 2. So it's going to be, so wait, let's erase this. So theta, okay. So theta here is going to become 0.9553. Okay. As we can see, we have now the upper and lower limits corresponding to the two theta. So we can substitute it now back. So this is going to become negative pi divided by 2. Um, 0.953, 1.0, I don't know, 1.171 second raised to 3 theta d theta. Now, if we input that in our if now we need to get the derivative of this. So let's first erase all the other unnecessary. Okay, so it's going to be equals to a second Okay, so it's going to become the same as the other formula. So it's second. Oh wait, no, I forgot about this. So no, second. So divided by two. So negative pi raised to divided by four second theta tan theta plus ln sec theta plus tan theta over 0.95553 1.10071. Okay, let's erase this bottom. Okay, now we can get the value of this. So if we input in the calculator, so it's going to become 1.8215, and that's the answer. This was a very long one, so let's move on. So let's clear all. Oh yeah, that was number two. I thought it was number one. Okay. Let's move on to another topic. So here we have centroids. And let's draw a random graph. I don't know. Undo. Let's draw a random graph here. So let's say this is a graph. As you can remember, B and the limits A and B refers to the corresponding x-axis, and C and D is on the corresponding y-axis. Okay, but let's say this um let's say from here to here, that's the x. But so from here to here, that's the centroid of x. So this is the symbol of centroid of x. The same can be also said for y. And let's say this is y, and this is the centroid of y. So this is y. This is the centroid of y. So in order to get the centroid of a problem, we need to get the centroid of x and centroid of y in order to get a coordinate on which is the centroid of the shape itself. And this is the formula we use for the what they call this for the centroid of under curves. This is a formula we use. This is for the centroid of y. This is for the centroid of x. And as you can see, there's slight differences in which in the centroid of y we have 1/2 y raised to 2, but in here in the centroid of x we only have x and y. So okay, so and here on the bottom we have the formula we need in order to get the centroids of areas between curves. As we can remember, in order to get the areas between curves, we need to first substitute. Let's say this is area between curves. So we need to substitute the no, we need to subtract the curves of this. So this is this is y2 and this is y1. As you can see here in the area between curves, the upper curve is y2 and the lower curve is y1. So just input it in the formula as the as that. So just finish the so just fully input it in the formula so that you can get the centroid of area between curves. So this is for under curves, under curves, and this is for between. Wait, it's glitching. So wait. So this is between curves. So okay, okay. Now let's get a example. Okay, let's clear this. Let's get to an problem. Okay, we're so in order for us to fully understand to easily use the formula, I put here in the right side. So okay, so let's first graph this function. So if we graph this, so oh yeah, I forgot to put here. So the limits are x. Oh no, wait. The limits are x is equals to 0 to x equals to 1. I forgot to input that here, so sorry for that. So if we graph this, it's going to look like it's going to look like something like this, where here it's going to this is 1 1. I don't know, 1 0 into this is 1 0 and this is 0 1. Okay, so in order to solve this, as we have a limit for the x-axis, so let's use a and b here. So and already have y here, so centroid of y is equals to 1 0 1/2. um that's going to become 1 minus x squared or dx divided by 1 0 1 minus x squared or dx. Now if we solve the integrals of this and the integrals of this is going to count 4/15 and this is 3, I don't know, but 2/3. So if we simplify this is going to become y. Okay, so this is going to become um Wait. So if we input it on calculator, so no, that's 415, not 15 4. 4, wait, 415 divided by 2 thirds going to equals to 2 fifths. So let's get the centroid of x. Okay, so this is going to become 10 x 1 minus x squared dx divided by, as it has the same value here, so that's going to be 2 thirds again, and equals to, if we find the integral of this, it's 1/4 divided by 2 thirds, and centroid of x is going to become 3/8. So let's say 3/8, that's 5. Let's say it's here plus 2 fifths. So wait. Let's say it's here. The centroid here is going to be is 3/8 over by 2 fifths. That's how we get the centroid of this shape. And if you remember correctly, the definition of centroid is where is the center of mass in an object. As this is a 3D two-dimensional plane, we can easily get that here by using the formula for centroids. Okay, as we already gotten our answer here, so our answer is, wait, undo. So let's just finalize our answer. So the answer here is 3/8 and 2 fifths. These are the coordinates of our centroid. So okay, let's move on to another problem. So let's clear out this and let's move to our last problem. Okay, let's first graph this. Okay, so um y is equals to x, so that's just going to become, oh wait, that's just become a straight line. So and y is equals to x squared. If we graph that, that's going to become something like this. And this is the area between curves that we need to find. Wait, our formula disappeared. Okay, now it's back. Okay. Now we can use our formulas to get the centroids in curves. So wait, undo, I need white. So y, the centroid of y is equals to, as we can see, the intercepts are here in based on the x-axis, it's 0 and 1. So integral of 1 and 0, 1/2. Here the y2 y2 is x y1 is equals to x squared based on the area between curves here. So that's going to become x minus x squared over dx divided by 1, 0. Um, x minus x squared over dx. Okay, now we can solve the integral of this. So using our calculator, we can get it. So x minus x raised to 2, no, x minus x raised to 2 raised to 2. Okay, with upper bound and lower bound of 1 and 0. Okay, oh, my neck hurts. So this is going to become 1 divided by 12. So, and for the for the denominator, it's going to become 1 over 6. So if we input that in our calculator, so 1, 12, 1 divided by 12, divided by 1 over 6. Okay, so y is equals to 1 half. No, what it's glitching again, so 1 half. So we need to find the centroid of x now. So 1, 0, so x minus x squared over dx. Just copy the value here, so it's the same here. So 1, 6. So let's find the integral of that. This is going to become wait. Hmm. So okay, so it's the same as the other one. So 1 over 1, 6, and x is centroid of x is equals to 1 half. So let's say 1 half is right here. Wait, need to get black. So right here, and 1 half is right here. That's the centroid of our shape. So centroid is 1 half, 1 half. And that's how we get the centroid of these two of the area between curves. Oh, man. Okay. And let's clear all this. And that's all for my video. Thank you for watching.